All right, this is the video of Avi and Benita's repair shop. It's an intro to exponential equations. So here's the intro slide. Avi and Benita run a repair shop. They need some help, so they hire you. They have different options for how much they'll pay you each day. You'll learn more about those rules in a moment. Just remember this: each day you get to choose whose rule you prefer. Ready? Continue to the next screen. So the table shows how much uh, you'll earn with each roll. Complete the table for day 4. So this is doubling here. So 1 cent, starting with 1 cent up to 8 cents. And Benita's rule is just adding 100. So um, Benita's rule is using is adding $100 each day. After day 10, uh, would pay more in the long run. Eva's rule would pay more. All right, so if I fill in the rest of the table, just doubling for Avi's rule, and then just adding 100. So adding in the next 5 days, it would look like this. So visualize the rule, Avi's rule is in red. Benita's rule is show blue. Describe what you notice about the graphs. In particular, how are they similar? And then how are they different? So you can't really see that this is exponential growth right now because of the scale of the graph. So Bonita is a slope line here. Avi would actually be exponential growth, but because of the scale here is 100, 200, 300, 400, then each of these is 100. You can't see that this is upward curve here, exponential curve. So both are line right now. They both look like lines. With Benita line having a steeper slope. All right. So on day 20, I think Avi's rule eventually we'd be paying more. So I'm going to guess Avi. All right, so this would be 10, 24, 20, 48, and then 40, 40, 96. So they don't give you any more room to type 14 through 19. But so 4096 times 2, this would be 14 times 2 times 2, 14, 15, 16. So 1, 2, 3, 4, 5, 6, 7. So this is 40, 96 times 2 to the 7th. So 5,000. This is 1,100, 1,200, 13, and then just be 20 with 2 zeros. So obviously approximately 5,243, and Bonita is 2,000. So now I can see that even though the scale here is 250 on day 20, Avi's up here and Bonita is still a linear there. So, uh, so Bonita, constant rate of change. Avi is exponential growth. So I have to look back at the table here to really get an idea of what's going on here. So on day 19, half of 5243 would be 2,800. So, I mean, be 2600. So 5243 divided by 2 would be 2, 6, 2, 1. So 2150 on day 19. And then on day 19 for Benita would be 1900. So that would be still more. And then 2150 divided by 2 would be 131. So 1310. So up to day 19. So back on this slide here. So if Cal is only going to work 18 days, then use Benita's rule. If he plans on working longer, then use this rule, Avi's rule. Instead of letting her decide each day which rule she'd like to get paid by, they're making D pick one rule from the beginning, and she has to stick with it. What advice would you give to D? Is there anything you need to know before you give sound and helpful advice? So same idea with D, depending on how many days she's going to work. So uh, and uh, you should pick Bobby's rule. So I already explained that. So Benita's rule is a line. A linear, Bobby exponential. In Algebra 1, you learned that an exponential function looks like this, where the variable is the exponent, and to find each consecutive term, we multiply by a constant number b. Exponential functions can be exponential growth or exponential decay. So usually call this a, the initial value, and then b is oh, the base here. So use a table of values to graph the exponential function. So if I put a -3 in there, it's 3/8. 3/8 comes out. If I put a -2, it's 3/4. it does. It just automatically turns it into uh, decimal values there. A -1 would be 3/2. 0 would be 3. And a 1 would be 6. And a 2. 2 squared is 4 times 3 is 12. And then if I sketch the curve through there, so it's probably a good idea to sketch a curve here. So this would look like this here. If I can get my pen to stay steady here. Not the best exponential curve, but looks something like that. All right, so here the table left it in fraction form: 3/8, 3/4, 3/2, 3, 6, and 12. What do we notice about f of x? What pattern happens in that table? So you're multiplying the previous value by 3. Here. Does that work? Let me see. 3/2 times 3, or times 2, sorry. This is the multiplier here too. So 3/8 times 2 is 3/4. 3/4 times 2 is 3/2. 3/2 times 2 is 3. 3 times 2 is 6. 6 times 2 is 12. So each y value is multiplied by 2. So how the values of f of x relate to the graph. So this 2 shows up here. It's multiplying the y values by 2. So it's actually the b value. So b equal 2, that shows up as the multiplier. Multiplier in the y column. All right, create a table for this new exponential function. So if I put a -2 in here, that would be 2 squared is 4. This is 12. And if I put a -1, you get a 6. So I get somewhat the reverse of the previous table. and a 0 would be 3. A 1 would be 3/2. A 2 would be 3/4. And then a -3 or +3 would be 3/8. Right. And if I sketch that graph through there, and it looks something like this here. Oop. All right, I kind of missed that dot there, but exponential decay. So the g of x, it should say f of x again, or I could make that g of x. So divided by 2. So decreasing. All right, so now we're getting into the features of the graph here. The domain would be -infinity to +infinity. And the range gets closer and closer to 0, but never reaches 0. So we're going to use the parentheses 0, infinity. I could say y is greater than 0. The right hand behavior as x approaches +infinity, of x approaches infinity, and on the left hand, as x approaches -infinity, f of x approaches 0. Because f of x equal 3 times 2 to the x approaches but never touches the horizontal line y equals 0. This is the horizontal asymptote. So this blue dashed line here is the horizontal asymptote. And then based on this equation, what's the growth factor? It's 3. And what's the horizontal asymptote? would be y equal 4. All right, so that's it does most activity there. Let me stop the video.